All right, guys, so today is going to be our last lesson. This is going to be over percentiles, and it's pretty related to what we did yesterday, so it's not going to be anything crazy. So let's see. The most important thing I would say is this definition right here. It's worth writing down, or at least making like a little blurb about. So percentile is the value in the data set where our percentage of the observations are at or below. So there's a percent of observations are at or below that value. You've probably heard like, oh, he's at the 90th percentile or something like that. And if someone said that, someone's like, that person he's a runner and his times are in the 90th percentile. He is faster than or equal to 90% of everybody. That's what that's saying to you. If this person is academically in the 90th percentile, they're better than or equal to 90% of people. So if you're looking at a curve of data, it would look like this. Here's the 90th percentile because 90% of the area is at or below it. Only 10% of the population is better than that person at whatever we're talking about. So again, a percentile is a value in the data set where our percent of the observations are at or below that value. If someone's in the 25th percentile, this could be a good thing. Like if you're like, oh, your body fat is in the 25th percentile. Okay, well, that's not too bad. So that's telling you you are here where 25% of the population is at or below you in terms of body fat. If you're running at the 25th percentile, I mean, it's not the best, but that means you're pretty slow relative to everybody else. You're only faster than like 25% of the population. All right. So here is an example of this. Somebody decided, I'm going to measure the circumference of baby heads. That's just what this person wanted to do. It was done by the National Center of Health Statistics. So they have a very official sounding name when they went to different babies with measuring tape. I'm like, let me measure your baby's head circumference. So this is what they ended up with. They got, big-headed babies, 38.6, smaller-headed babies, 32.2, and their percentiles for each of those. So most baby heads circumference for these boys is 38.6 centimeters or less, 95 percentile right there. And so if you're watching the video, you can like always pause as we go through this. Or you can speed up, it kind of depends. I'm gonna give you guys a second to think through this. What percent of newborn boys had head circumference greater than 37? So we're going to find 37. We want to think about what percent are greater than 37 centimeters. I'll pause for a second. Did you guys get 25%? Because they're at the 75th percentile, so greater than would be 25%. Less than or equal to would be 75%. That's how percentiles work. They're always less than or equal to. They always go to the left. So 75 percentile, this is bigger than 75%. It's smaller than 25%. All right, next one. 10% of newborn babies have head circumferences bigger than what value? So 10% are larger than what value? Give you a second to look for it. You can do this. Ooh, that's a good answer. It is. So 33.2 would be the answer if it said 10% of newborn babies have head circumferences smaller than or equal to what value? Because percentiles always go left. So this 10% right here, which is a good choice, that's dealing with left. So that'd be less than 33.2. If you want to find 10% of newborn babies have head circumferences larger than a value, you want to look over here. They're at the 90th percentile. So only 10% of the babies are bigger than 38.2 because 90% are smaller than 38.2. Okay, let's look at this real quick. I can draw a picture. Pictures can help. Okay, so let's say this is that distribution of baby heads. It's probably about normal. And this was that 38.2. They're at the 90th percentile, and that's telling you that 90% are less than or equal to that 38.2. Good so far? And so that would mean that 10% have to be larger than 38.2. Still good? If 90% are less than? So the question said 10% of babies have head circumference larger than what value? So 10% have heads larger than 38.2. And so for percentiles, they can either ask you for stuff to the left or the right, and it's really going to be dependent on the phrasing of that question. So in this case, 10% have larger than what value? So 10% are larger than 38.2. It's kind of the same question as the one above, where we had to go to the left based on what they were asking. This was asking for greater. Now here, this one's a straightforward question. It's meant to be straightforward. What head circumference is at the 25th percentile? So we just find 25th percentile, and 34.5 is at the 25th percentile. What head circumference is at the 5th percentile? Again, straightforward, 32.2. Boom. Now this one's going the other direction. It says what head circumference is at the top 5%? So you're thinking about big-headed babies, top 5%. So the top 5% is at the 95th percentile. That's the top 5%. Because 95% are less than or equal to that value, which means they're in the top 5%. So 38.6 centimeters. I'll give you a second for this one. Did we get 50% or 50th percent? 50th percentile? Yes? No? Okay. And then the last one, I think this is the last one. It says, what is the percentile rank of a head circumference of 33.2 centimeters? So 33.2 is going to be 10%, or the 10th percentile. Yeah, that's about all I got to say about that. That's the end of the unit. So we're going to look at a practice problem now. Everybody loves practice problems. Students are always like, can we have more of those? And I'm like, all right. You guys insist. So this is today's homework, which is one that you have to turn in. So don't forget to turn this in. It's going to be a mixture between the empirical rule, which we learned yesterday, which we just kind of reviewed earlier. That's that if you get the middle 68%, that's within 1 standard deviation of the mean, then 95, 99.7, that sort of thing. That's the empirical rule. And then today's thing, percentiles, those typically deal with at or below a specific value. There's going to be crossover here, though. There's going to be some crossover between the empirical rule and percentiles. There's kind of a mixture of yesterday and today. So some more people got a hold of babies, it seems. This time they're measuring how long the babies are at the Valley Hospital. And so it says, first of all, they were normally distributed. These babies are normally distributed in terms of baby length. The average was at 50, so 50 right there. And the standard deviation sigma is 3.5 centimeters. And I highly recommend you get in the habit of drawing these little curves and shading them. I think it really helps. So we want to know what percent of the babies are between 43, which is 2 deviations to the left. This is 43. That's 7 away, which is 2 standard deviations. And 53.5, which is 1 deviation to the right. So 53.5. So we want to find this percentage. In order to do that, we're going to go to our old blank piece of paper. And we're going to talk about kind of what we did yesterday. This is an empirical rule question. Yeah. No worries, though. That's the whole point of practicing it. So it's better to get that out of the way before the test. So what we want to do is consider two different curves. The first type of curve, we're going to go 2 deviations away on. That's where we get that 43 right here. So if you go 2 deviations from the average, so here's mu plus 2 sigma. This would be mu minus 2 sigma. 2 deviations to the left, 2 deviations to the right. This is going to be 95% of the data. That's what the empirical rule says, or approximately 95%. And so using simple math, we can say, all right, well, if we have 100% of the data, and we've already used up 95% of the data, there's 5% left over. Well, that's telling you that the tails here and here have to be a total of 5%. If the middle's 95%, the tails are 5%. So this is going to be 2.5% and 2.5%. And that's how I know this piece right here, this little tail right there, is 2.5% based on this picture. And also, draw another normal curve. This time we're going to go only 1 deviation to the right and left. So that's going to be the average, and now we're here, which is at that 53.5. In this case, when you're 1 deviation, as you draw along the same. Wait, what? Oh, why am I always drawing the same curve? Because they're always normal. They said that they are normal, and normal curves always look like this. Like these are what normal curves look like. And it won't change. They always look like this. They can be taller, shorter, but they always look like this. I would say the vast majority of stuff in this unit is normal. The first part of the unit, which was like linear combinations and populations and transformations, linear transformations and then population combinations, sorry, those were not necessarily normal. But for the empirical rule, absolutely always normal. For z-scores, usually normal. Not always, but usually. All right, so looking at this problem, we have that 53.5. This is the middle 68%. Again, that's within 1 standard deviation to the left and the right. This is 68%. Using some simple math, 100% minus 68%. That leaves us with 32% for these 2 tails. So that means that this tail and this tail have to each be 16%. Not drawn to scale, apparently. I didn't put the lines far enough over. So these are each 16%. That's how I know this piece up here is 16%. And so we can finally answer this question. And you'll start noticing these numbers repeat a ton. Some of you are like, yeah, those are the same numbers from yesterday. And it's not going to change for the empirical rule. So the probability of being between 43 and 53.5 inches is going to be 100%. And we're going to subtract 2.5 and 16%. So 100% minus 2.5% minus 16%. And that's going to give us our final answer of, dramatic pause, 81.5%, I believe. Yeah. It's okay? Cool. Cool. All right, let's do 2 more examples. For B, again, I would draw the normal curve because they said it's a normal distribution. So I'm going to draw this normal curve. And it says, what percent of the babies are longer than 57 centimeters? So here's the mean of 50. 57 is going to be 2 deviations to the right. So 57 would be like right here. And we want to figure out this. We want them to be larger than or longer than 57. So this little piece right there. So going back to my little scratch piece of paper, we already kind of solved this. If you go 2 deviations to the right, we already know what that answer is. It's 2.5%. That's it. So the probability of getting a baby that is longer than 57 centimeters is apparently 2.5%. We'll do one more problem together. This last one right here. C. So this one says a length of 46.5 centimeters corresponds with what percentile, which means at or below that value. So what I'm going to do is draw again the normal curve. This is the process you want to be doing for these problems. Draw the curve. The mean is at 50 still, and 46.5 is 1 deviation to the left. 46.5. 1 deviation to the left. And it wants to know what percentile it's at, which means at or below. So that's telling you you're going to shade left. That's at or below that value of 46.5. And again, we've already figured this out. We already did this. If you go 1 deviation to the left, then that's going to be 16% to the left. So this would be at the 16th percentile. And that's about it. And I've left you with only 2 problems, which is a classic math teacher thing, because when you look at number 3, and it's not one, it's like multiple parts to it. So it's not really 2 problems. But there's 2 more questions. Some have multiple parts. You can ask me questions if you have them. I'm going to hopefully end this recording, and it'll hopefully take this time